Okay guys, so let's look at the second example on the sine rule. Okay, so now I'm just going to write the sine rule here, which says a sine that. I'm just going to write part of it, not the whole lot of it, and sine b. All right, so this is what we established in the previous video on the sine rule. So there is this question 2 which says find the value of x. Okay, so this is the x that we've got. So we need to look at, before we use the sine rule, we need to make sure that of the 4 things that we've got in our formula there is just one thing missing. So if you look at this angle here, it's got its opposite side, which is nicely done. And then if you look at this side here, it's got this angle also here, it's got its opposite side given. So there's just the angle missing. All right. So we can go ahead and just name our angles A, B, and C if you want in this case, which means our small a would be the 39, and then our small b would be the 24. So what this question wants us to do is to find the x, the value of x, which is the angle in this case. So for the good of using the space, I'm going to start my work in here. So in this formula, we need to put, where there is a, we put 39. So we're going to have 39 over sine a. Our a is going to be the 71.8, so it's going to be sine 71.8, all right, equal to our b is the 24, which is the side, the 24 over sine x. So it's now just going to say sine x. Now, as I always say, when you are dealing with fractional expressions or equations, cross multiplication is always the best way to go, so that you can make your equation into a linear kind of operation. So we need to cross multiply here, and this is just basic mathematics, and I always discourage students to write the value of these sine and cosine, whatever questions. So in this case, we'll maintain our signs until further notice. So if we cross multiply 39 times sine x, what we are going to have is 39 sine x equals to 24 sine 71.8. We'll keep the sign, because once we expand them or we evaluate them, we are going to have decimal numbers, and it will lead to us rounding up prematurely. So let's keep them for now and see how we work with these things. So now if you look at this, what we need is the sign. We need to remain with the sine x here, implying that we need to divide by 39 and divide by 39 on both sides, so that those can divide. So it's like we've got sine x equals to, now you get your calculator and punch 24 times sine 71.8. all right, once you find the value, you now divide your answer with or by 39. Okay, so doing that nicely, according to me, it will now lead you to some expression that you are going to have, which would be about, I'm not so sure what that is. So whatever you get on your calculator, let me just do that quickly. 24 times sine 71.8, all right, divided by 39. You are going to get sine x equals to 0.58459 and some decimals, so on and so forth. So this is the value you are getting from this, all right. But then, you know, what they are asking us to do is to find the value of x. And if you remember very well from our Pythagoras theorem and the trigonometric ratios that we were doing, to find x, we need to find the sine inverse of this answer that we've got here. So we are going to say x would be equal to the sine inverse of 0.584 with whatever that is, okay? So if we do that, you'd find that your x is going to be 35.8 degrees to 1 decimal place. How we find the sine inverse is what we did in the previous videos. You just go on shift or the second function, which is top left corner of your calculator, press on the shift and then go back on the sine button. It will give you the sine inverse. Then punch this decimal number as it is on the calculator. Don't miss out anything, otherwise it's going to affect your final answer. And we always say that angles should be written to 1 decimal place, and this is the answer to 1 decimal place. So then it implies that the value of x is now going to be equal to 35.8 degrees. So it is important that you understand how to use the sine rule. It's just having one side and the angle, and then you look at the opposite side to be your A. Again, if you look at this angle here, this would be our B if we want. The opposite side, the length there, would be the small letter b. So it is important that we understand this rule here. This is just part of the rule. The rule extends to C over sine C, but we just use 2 parts of it. So it is very important that we understand the sine rule. If there will be other examples that I'll meet that would be interesting for me to share with you, I'll share it on my special edition. But to just conclude on the sine rule, this is important that we understand that this part of the sine rule that we use is A over sine A equals to B over sine capital B. Now the A is the opposite length to the angle A. You've seen I named this as A, meaning this length that is opposite to A would be my small a. B would be this angle named B, then the opposite length to this same B would be your small b, and then you just make your substitutions nicely. So it's a very simple and nice concept, and it requires that you practice more to understand it better. Then as I conclude on the sine rule as well, avoid finding the value of these signs before the final answer. Like if you've seen here, I kept my sine 71.8 because if I punched that on the calculator, it was going to give me a long decimal number, and I was going to be forced to start rounding up or down, which would have eventually affected my final answer. So it's important that you keep these for as long as you can, and then come and use your calculator nicely at the very end of your calculation, because rounding up or down before the final answer would affect the accuracy of the desired answer. So thank you very much, guys, for your time, and please like my YouTube channel, which is IGCSE Zambian Tutor, and then my Facebook page, which is Math Antenna. So thank you very much, and watch out for the next rule, which is the cosine rule, and see how we can use that on 9 right-angled triangle.